Hello and welcome back. In our last video, we created a data entity that provided a foundation for integrations. Now we'll build a more advanced integration to solve a critical business problem for our client, Bluestone Industrial Components. In many businesses, a credit hold is a standard financial control. It's an automated process where the system blocks new orders or shipments to a customer, usually due to an overdue invoice. While this is a necessary safeguard, it can create significant problems if it's applied blindly, especially to top-tier partners. This brings us to the core requirement from their sales director, Mrs. Gill. She explained that a platinum customer, one of their most valuable clients, could be put on a complete credit hold over a very minor issue, like a single small disputed invoice. This action would immediately halt all their shipments, potentially disrupting their operations. The biggest issue is that the sales and account management teams are often unaware this has happened. As Mrs. Gill told us, my team only finds out about a problem with a top client when that client calls to complain. This reactive situation is damaging to the business relationship. Our goal is to build a proactive alert system that notifies her team the instant a platinum customer is put on credit hold, giving them the chance to intervene immediately. We'll accomplish this using a technology called business events. A business event is a notification mechanism. Instead of an external application inefficiently polling Dynamics 365 by repeatedly asking if something has happened, we'll enable Dynamics 365 to send out a broadcast the moment a specific important action occurs. This event-driven approach is real-time and highly efficient. To create our business event in Visual Studio, we'll build a few components, starting with our contract class. First, we'll right-click on our project and click on Add New Item. Under the Code section, select Class and name it BIC Cust Credit Hold Business Event Contract. In the same way, we will define the business event. We'll create a new class and name it BIC Cust Credit Hold Business Event. Now that we've defined what the event is, we need to define when it should fire. We'll do this in a new, separate event handler class called BIC Custable Event Handler. Now coming back to our contract class. The purpose of this class is to define the payload, which is the specific package of information our event will send. Looking at the code, we can see a few key things. The class extends the standard business events contract, which is a requirement for it to work with the framework. Inside, we've declared private variables for the three pieces of data we need for our alert: cust account, cust name, and cust year. To make this data accessible, we create a public PARM method for each variable. The most important part is the attributes above each method. The data member attribute gives each piece of data a machine-readable name, like customer account, that external systems like Azure Logic apps will use. The business events data member attribute provides a friendly, human-readable label, like customer account, which will appear in the user interface when we configure the integration. Finally, we've added a static helper method called newFromCustTable. This method allows us to easily create a new, populated instance of this contract directly from a customer table record, which will simplify our code in the next step. Now we will open the business event class we created earlier and understand its structure. The most important part of this class is the business events attribute right at the top. This is where we register our event with the system by providing four key pieces of information. First, we link it to our BIC Cust Credit Hold Business Event Contract. Second, we give it the user-friendly name Platinum Customer Credit Hold Alert. Third, a clear description of its purpose. And finally, we assign it to the customer module for organization. Although for the sake of this explanation, I have explicitly added a string. The best practice is to make use of the labels, the details of which I have already covered in the previous videos. Inside the class, the essential piece of code is the buildContract method. This method is required by the framework, and its job is to call the helper method on our contract class, which packages up the customer data whenever the event is triggered. Now let's go to our event handler class and understand its code. Inside this class, we create a single static method, custTableOnUpdating. We decorate this method with the DataEventHandler attribute, which acts as our trigger. This powerful attribute tells the system to automatically run our code every single time a record in the customer table is being updated. The logic inside this method contains our specific business rule. First, we get the original customer record from before the changes were made so we can compare the old and new values. Then, our code checks for a sequence of conditions. Was the credit hold field actually changed? Is the new value for the hold all? And finally, is the customer's tier platinum? Only if all three of these conditions are true, the final line of code execute. This line creates a new instance of our business event and calls the send method, which officially fires the event and sends our data payload out of the system. Finally, just right-click on the project and click on Build. With our X++ code in place and the project successfully built, our business event is now technically part of the application's code. However, the Dynamics 365 user interface doesn't automatically know about this new event yet. We need to explicitly tell the system to find and register it. To do this, we will navigate to the main dashboard. From there, we go into the System Administration module, and under the Setup section, we click on Business Events Catalog. This page lists all the events the system is currently aware of. If we search for the new business event we just created, we would see that it's not yet populated here. To make it recognize our new one, we need to go to the Manage tab in the Action pane at the top. Here, we'll find the option Rebuild Business Event Catalog. Clicking this button kicks off a process that scans the application's code, discovers the Platinum Customer Credit Hold alert that we defined with our attributes and officially registers it. After the rebuild is complete, we can search within the catalog, and we will now see our new event listed under the customer category, ready to be activated and used. At this point, our new business event is working perfectly on our local development environment. However, this environment is a private sandbox running on a local virtual machine, which means it's completely isolated from the public internet. This presents a challenge because Azure Logic Apps, the cloud service we need to catch our alert, cannot see or communicate with an event running on a private machine. To bridge this gap, we must deploy our new code to an environment that Azure can connect to. Here, we can use our sandbox environment that we deployed earlier using LCS, as it is internet-facing. By deploying our code there, our new business event becomes visible to Azure. The first step in this process is to package our customizations. I'll quickly create a folder for storing our packages. In Visual Studio, we'll navigate to the top menu to Extensions, then Dynamics 365, hover over Deploy, and select Create Deployment Package. This opens the Create Deployment Package wizard, which displays a list of all the models in our solution. We need to find our specific model, BIC Customer Management, and select the checkbox next to it. Here, we can update the folder where our package will be exported. With our model selected, we'll click the Create button. Visual Studio will then begin compiling the code and packaging all the components. This process will take a few minutes to run. Once it's finished, a single zip file, our software deployable package, will be generated in the specified location, ready for the next step. With our deployable package ready, our next step is to upload it to Lifecycle Services. After logging into our project in LCS, we'll click the hamburger menu icon in the top left corner and select Asset Library. This is the central repository for our project's assets. Inside the Asset Library, we'll select the Software Deployable Package section from the list on the left. To add our new package, we'll click the plus icon. This opens a pane where we'll give our package a meaningful name and a brief description of its contents. Next, re-click the button to upload the zip file we just created in Visual Studio. Once the upload is successful, we'll click Confirm. Our package will now appear in the Asset Library list, ready to be deployed. From here, the process of applying the update is very specific. Back on the LCS project dashboard, we'll navigate to our Cloud Environments Details page by clicking the Full Details link. Once the environment page loads, we'll find the Maintain menu at the top. Clicking it reveals a drop-down list of actions, and from here, we would select Apply Updates. This opens a new view where we can see all the packages available in our asset library. First, we'll give a name to this update for tracking purposes. Then, we'll select our specific package from the list and click the Apply button. A final confirmation window will pop up, asking us to verify the action. We'll click Yes. LCS will then redirect us back to the Environment Details page, where we can see that the deployment has started and the environment state has changed to servicing. This is a fully automated process that will take some time, so we will allow it to complete. With the deployment to our cloud environment complete, our first step is to verify that the new functionality is active. We will now log back into our Dynamics 365 Cloud instance. Once logged in, we will navigate to Modules, System Admin, and then open the Business Event Catalog. Now, we will sort the records by category. As we can see, a quick search now finds our Platinum Customer Credit Hold alert. This confirms our code was deployed successfully and the event is ready to be connected. Now, we'll switch over to the Azure portal to build a workflow that will catch this event. We'll search for Logic App in the home screen and click on the icon to open the page. From here, we will click on the Add button. The first decision is choosing a hosting plan. For this demonstration, we'll select the consumption plan. This plan suits our purpose because it's a pay-per-operation model, meaning we only incur costs when the alert actually runs, which is very efficient for workflows that aren't constantly active. After selecting the hosting plan, click Select. On the main configuration screen, we fill out the project details. If we already have a resource group, then we can select it. Otherwise, just click on Create New, enter a name, and then click on OK. After that, we can provide a unique name to our Logic app under Instance Details. For the region, the best practice is to select a location that is geographically close to your Dynamics 365 environment to ensure the lowest possible network latency. After that, we proceed by clicking Review plus Create. This brings us to a final summary page where we can verify all the details we've entered. Once we confirm everything is correct, we'll click Create. Azure will then provision the Logic App resource. Once the Logic App resource is ready, we'll open it and click the Edit button to go into the Workflow Designer. The canvas will be empty, so we'll start by clicking Add a Trigger. In the search box, we'll type Fin and Ops and select the When a Business Event Occurs trigger from the results. Here, you will be prompted to sign in. You can just sign in with any account. Now, we just need to configure it by selecting our Sandbox instance, setting the category to Accounts Receivable, and choosing our Platinum Customer Credit Hold Alert from the Business Event dropdown. This completes the When This Happens part of our workflow. Next, we'll add our Do That step by clicking Add an Action. We want to send an email, so we'll search for the Outlook connector and select the Send an Email V2 action. Next, just click on the Sign In button. Here, you need to sign in with an account that has access to Outlook email. By doing so, you are granting this app permission to send email on your behalf. Consequently, whenever an automated email is triggered, this email address will be displayed as the sender. Here, we'll configure the email details, starting with the recipient's address. I'll just provide my Gmail ID for testing. Next, we can add the subject. In order to dynamically populate the customer name, we can make use of functions. We can add this by writing an expression, for example, trigger body, customer name. Finally, click on Add. The text inside the quotes, like customer name, must exactly match the data member attribute we defined in our X++ contract class. Finally, we will build a detailed email body, inserting the dynamic content for the customer's name, account number, and tier to give the team all the information they need. With our trigger and action now fully configured, we'll click Save in the top left to finalize and activate our Logic app. Our end-to-end alert system is now active, so we can test the entire process. Now, back in our Sandbox environment, click on the three lines, then open Modules. From here, under Account Receivable, open the All Customers form. Now, let's select any random customer for demonstration. We'll click on Edit, then update the customer tier to Platinum, and then save the changes. Now, we need that on hold field to demonstrate the business event. For that, under Options, click on Personalize this page. After that, select Add a field. Here, we will filter the column Invoicing and Delivery on hold. Finally, click on Update button. Now, let me close the pop-up. Here you can see the field has been added and it is having a value No. We will change it to All to block the customer and save the record. Switching to the designated email inbox, we can see the notification has arrived almost instantly with the urgent subject line and the customer's details in the body. This confirms that we have successfully built a fully automated, real-time, event-driven alert system that directly solves our client's most critical problem. In this session, we covered the complete end-to-end process. We authored a custom business event in X++, deployed that code from our local machine to a cloud-hosted environment, and then used an Azure Logic app to create an instant notification workflow. Thank you for joining this session. We'll see you in another lecture.